I've introduced the scale of the universe. Like, what does that mean to you?
Atoms are like the fundamental building blocks of everything we understand, but you'd be surprised that there's things even smaller than atoms, like protons, neutrons, and electrons.
Can you tell us about neutrinos?
I know they're fast. I know they're very light, or almost massless, which means they are very close to the speed of light, which is pretty cool. We believe that neutrinos appeared after the Big Bang. However, my theory is that we were born out of a true vacuum universe, which would mean that neutrinos and all of the other particles are, in fact, around. Which would also mean that our universe isn't the limit of the scale of our universe.
So can you speak more about the scale? Like, what comes after atoms, us, Earth?
People, Earth. You know, you got your planets, Venus, Mercury, Earth, Mars, so on and so forth. You got the sun, then the solar system. We are not actually in a cluster. We're on the outer edges of the Milky Way in the very thin lining. So we're like a lone star system. You have the Milky Way, and then our closest major galaxy, which is in the Andromeda Galaxy, also M31. It's also known as M31. There's smaller galaxies in between, but I can't remember the names. The largest globular cluster, which is a star cluster, is called Mayal 2, and it contains 12 million stars, and it's between us and Andromeda. Then you scale out larger, you get to superstructures like the Kipu superstructure, which is a bunch of galaxies really close together that we didn't think were possible before. It stretches about 1.5 billion light years across, which is insane, since like I'm pretty sure, yeah, our galaxy is only like 250,000 light years across. It's insane to have billions. Then you have like, what's it called? The Boss Great Wall, which is 1 billion light years across, and it's like a line more than a structure in a sense. And then there's, zoom out even further, you get Cosmic Web, which is it dictates how matter is distributed around the universe. And a fun fact actually about the universe is we know it's empty space because space, right, the name. 85 to 90% of the observable universe is dark matter and dark energy, which is actually really interesting because dark energy is nothing like normal energy. So obviously it's a different type of matter as well. It's not normal matter. It's not like Earth, carbon, oxygen, this, that, the other. It's a different kind. It's visible, but it's not visible. Like, it's invisible to the human eye. You can only detect it with tools, which means that, you know, it's always there, but you can't see it. And then you zoom out any further past the cosmic web, since the cosmic web is literally the biggest structure in the universe, and you hit the edge, which is or maybe it's not an edge, maybe it's a wall, maybe it's not anything at all, maybe you can pass it.
Do you have any theories on what's beyond our observable universe?
I have one theory. I believe that a bunch of particles came together and collided in a true vacuum universe, which would create enough energy, the Big Bang, to expand out a false vacuum universe with mass. And that is why it is expanding super quick. That also means that I believe that the heat death of the universe is very likely just because of how much energy we have that is expanding, that separates stars. That means that stars will eventually burn out and die. But I also believe that it's possible that we get the other outcome, which is it expands until it runs out of energy, and then it closes in on itself because there's something else outside of it anyways. What do you think?